In this video, we are going to be going over the Unit 2 practice test. So we'll do an example together. We'll do like question 1, we'll do all the odd questions, and then you'll have an opportunity to practice that question immediately following. So let's look at our first problem here. We are translating, so we're describing the rule that we're seeing here. So if you notice, this is our original figure. And then we know this one here is our new figure. And we know this is our new figure because it has our prime notation here. So if we were trying to figure out how we are getting from the original to the new, it is a translation. They're in the same orientation, but we want to know how many units we are moving. And it looks like we're moving to the right, and it also looks like we're moving up. So we're moving to the right, 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3. So I just picked Q, for example. You can pick any point and also verify that that works as well. So we're moving to the right 8 and we're moving up 3. So for this one, I would select answer choice A. Now you're going to try answering question 2. From the original figure to the new figure, how many units up, down, left, and or right are you moving? Okay, let's look at question 3 here. We are going to do another translation, but this time we are going to write a rule for that. So here we have our original figure, and then we have our new figure. And let's just figure out how many units we're moving. So let's just examine M. It looks like here I'm going up 1, 2, 3, 4. So I went up 4 units. So right now my rules are not written as words, they are in our notation here, our transfer or translation rule. So if we want to determine what the rule is, well, maybe we can go back and look at our toolkit. Scroll down. Oh, actually, let me see the toolkit answer key for this portion is here. Here we go. So looking back on your toolkit, we want to know how we're shifting on a graph if we move up. So we said we were moving up 4 units. So up 4 units means y plus. And since we did not shift left or right, I would not be adding or subtracting anything to x. So it looks like here y plus a number, and we're moving up 4. So let's go back. Here we're moving up 4 units. So x, nothing is happening to x, but y, we are adding 4 to that. So I'm going to circle question A for number 3. And then you are going to take an opportunity to answer question 4. Decide how many units up, down, left, or right you are moving, and then create the rule for that. All right, question 5, 6, 7, and 8 here. I'm going to give you a moment to try. First, we want to examine in our toolkit all the different types of reflections, or the 4 main types of reflections that we're studying. So let's go back to our toolkit. We've got translations here, and let's go to our reflections. Let me zoom out just a little bit. There we go. So with our reflections, we want to first notice, okay, what type of reflection? So the first one that we have here is an x-axis reflection. So this is the x-axis. You'll notice we have something above the line and then below the line, and it's actually kind of reflected onto itself. So each point is the same distance from this line, this x-axis. For our y-axis, this is our y-axis here. And you'll notice on both sides of the y-axis, we have an identical image. Here we have our y equals x. Remember, this line y equals x is basically like saying y equals 1x plus 0. Start at 0, up 1, right 1, up 1, right 1. Or you could also just say, well, whatever x is, y is the same. So if you can have a point at 0, 0, 1, 1, 2, 2, 3, 3, and so forth. And so you'll notice the reflection on both sides of that line. And then our y equals negative x is here. So now what you're going to do, and you can get your toolkit out and go to this page as well in your toolkit. Now you're going to try answering our questions about reflections. So I'll give you a moment, answer question 5. Okay, now let's try question 6. Which type of reflection is this? Okay, now let's try question 7. And let's answer question 8. Okay. And our last type of transformation here, these are our rotations. So we'll go back and reference our rotations here. I'm going to scroll down to our rotations on a coordinate grid. So if you'll notice here, we have all counterclockwise. So we have 90 counterclockwise, but I also wrote here on the bottom that's the same as 270 clockwise. And then we have 270 counterclockwise is the same as 90 clockwise. And then obviously 180 is the same either way. So one thing I want you to notice is on our practice test and on our test, the only types of rotations here that we're going to have are 90 and 180. And so we're only moving 90 clockwise or counterclockwise or 180 degrees. And it's not going to tell us a direction. So these 4 questions are going to be rotation questions. I know they give you some other options here, but they are all rotation answers. So let's look here. So really what that means is we're going to be looking at 90 counterclockwise. Okay, that's what we have here. And then instead of using 270, we're going to use 90 clockwise. So these are the 3 rotation options. And then your 180 is just going to be, neither direction. It doesn't necessarily say. So we've got 90 counterclockwise. We've got 180 as an option. And then we've got, 90 clockwise. So let's take a look here. We know this is our original figure. And this is our new figure. So from original to new, you can kind of see here that it's rotated 90 degrees. We're rotating it around the origin, right? So you can also tell, well, if I go from F to my origin to my new point F, well, I just created a 90-degree angle there. F to new point, F to the origin to the new point F. You can also check that with G, origin, new point G. You can also check H to the origin to the new point of H. So that was what our 90-degree clockwise rotation looks like. Now here we have a 180 rotation. So you can essentially see our original figure was almost like turned upside down here. So you can check if I take any point here and I connect it to that middle point, it should create a straight line, which is 180. So I've got J. If I went through the origin to J, that would create a 180 degrees. H to H through the origin, and then I to I through the origin. And then lastly, we've got our 90 degrees clockwise rotation. So this is clockwise, and it appears through the origin. And so if we're looking at 90 degrees, we should, from the original point to this point of rotation, the origin to the new point, be able to create a 90-degree angle there. Should also work with G. And I'll just show this in G to the origin to the new point. Oh, there we go. It's a 90-degree turn. And then H to the new point of H. So now I'm going to give you a moment. I'll let you first try this one. For the first question, I'll go ahead and draw in the arrow. You're going to be answering question 9 now. So we have around the origin, and we're rotating. Looks like if this is the original, this one's the new. So now you're deciding what type of rotation that is. Okay, let's answer question 10. Here's our original figure, the new figure. And let's take a moment, answer question 11. And we'll finish our rotations with question 12. Okay. Next, we're going to look at finding a new coordinate point based on some type of rule that we have here. So back to our rule, it says x plus 4, and then just a y. So if we want to reference our toolkit, we can. So let's go back, and that was on this one. So x plus a number, so that means I'm going to the right. And then what did it say about y? That didn't do anything for y. So x plus 4, that means I'm moving to the right 4 units. So I can go over 1, 2, 3, 4. That would be my new coordinate point here. If you want, you can also just take the coordinate point, u. U is at -1, -1, 2, 3, 4, 5. Let's write that out, -1, -5. And you can just add 4 to x. So if I take -1 and I add 4 to that, I'm going to be at 3, -5. So here's our new point, 3, -5. So you can really do that in two ways. You can do it by graphing, or you can just do it with the coordinate rule. So now I've got u, the new point for u is at 3, -5. Using this as your example, if you want to get your toolkit out as well, I'm going to let you answer question 14. Okay. Here we're going to do this 6 units to the left and 2 units down. For this one, I'm just going to go ahead and actually do the transformation on the graph since I have a graph here. So 1, 2, 3, 4, 5, 6 to the left and 2 down. And then I'll call that P prime. And that is now at -1, -5. And I'll write that out, -1, -5. So we've got D as our option. If you want to, for this one, check this algebraically, you can as well. Your rule for this would be x minus 6. You're moving to the left. Y minus 2. And if you wrote out your original coordinate as 5, -3, you could also just take this and just say, okay, well, let me take 5 and subtract 6. Oh, good, that'll be -1. And let me take -3 and subtract 2. And that will be at -5. Okay, now you're going to try 16. Okay, now we're going back to our reflection rules. So reflection across the x-axis. Well, let's remind ourselves in our toolkit what our rule is for that. So we've got reflection on the x-axis. Here's our rule, x -y. Here we go, x -y. So I'm going to write that down here. X stays the same essentially, and y is being multiplied by a negative. So if we look at our coordinate here, the 4 is going to stay the same, and our -3 is going to become a +3. So we can just write that out as, I'll just circle my answer, 4, +3. So x stays the same, and our y changes signs essentially. So this will be our answer here. I'll let you try number 18. This rule is the same for that. Okay, let's look at question 19. We're going to reflect across the y-axis this time. So our rule is -xy. So if we have a -xy, -x, that means the y stays the same this time, and our x is changing signs. So if our x is changing signs, that means this 3 is becoming a -3, and 0 is going to stay 0. So -3, 0. This will be answer choice D. Using the same y-axis rule, so go ahead and solve question 20. All right, so now we're going to look at our y equals x. For that, we are switching the location of x and y, I'll notice here. All right. So I'm going to write that rule in. So x comma y becomes y comma x. So if I take a look at my coordinate here, all I'm doing is switching the location of these two. So if x comma y becomes y comma x, I would write this as 5, negative 4. So 5, negative 4 would be option D. Okay, give you a moment, answer question 22 with the same y equals x rule. Okay, and our last one here, y equals negative x. It looks like they are changing signs and they are switching places. So I'm going to write out negative y comma negative x. So basically xy is doing this. So I'm going to change the location of these two things. So I'm going to put in a parentheses here. I'm going to put 2 here, and I'm going to put 1 here, and then let's change the sign. So 2 was positive, so let's make it negative. And 1 was negative, so let's keep it as a positive. We're changing the sign. So then I would have 1 comma negative 2. All right, take a moment and answer question 24, and you are using the same rule. Okay, now we're going to practice with 25. We have a 90 degrees counterclockwise about the origin. So let's get our rule from our toolkit. So 90 degrees counterclockwise from the origin. Looks like our rule is, negative y comma x. Let's write that rule down, negative y comma x. So it looks like I'm changing their places a little bit and I'm changing the signs of some of them. So this one is probably not the best example, but what we have here is negative 3 and negative 3. They're changing places. So, well, if I change their places, they're just going to be the same number. And they're changing this one here. That's our y. That's changing signs. So when I bring it here, this is going to become a positive. So let's first go ahead and put them both as negative. There we go. So I switch their places. Let's pretend this was this one here. Let's pretend that goes to here. And I'm changing the sign of just this one, the y. So I'll make that a plus. So our coordinate would be 3 comma negative 3. Let's write that in, 3 comma negative 3. There we go. Maybe let's look at the example that we have, a better example, where the numeric values are different. So let's take a look maybe at, for example, this one here. We've got our coordinate f at negative 3, negative 2. Great. And our new coordinate f, oh, I didn't even write this on my toolkit correctly. The coordinate for that is 2, negative 3. So let me put that there. So what you're noticing happening is negative 3, that's the x. It stays the same. It's going into the x location, which is now here. And then our y, which was negative 2, changed signs and it went to the front. Okay, and we can check with one other coordinate point. We can check here. This 2 remained a 2. Great. This negative 4 switched to this location here, and the sign changed. All right. Our next rotation is, oh, sorry, let me give you a moment. You're actually going to be answering question 26. Go ahead and answer that using this 90 degrees counterclockwise. All right, now we've got a rotation of 180. Let's go back to our toolkit. Looks like it's a negative y comma negative x. Whoops. There you go, negative y comma negative x. All right, so I'm going to rewrite this. I'll put the negative 3 here, I'll put the negative 2 here, and it looks like they're both changing signs. This will become positive, this will become positive. So we've got a 3 comma 2 as our solution. 3 comma 2. What did I do? Let me check. 180. Oh, 180. I am not changing their locations. Excuse me for that. Let's see. It's just supposed to be negative x comma negative y. See, teachers make mistakes as well. Let's erase that. All right, so hopefully while you were watching that, you were like, oh, Miss Reese made a mistake. Need to go back. Negative x comma negative y. So we're not changing their places. All we're doing is changing their signs. So then we've got a 2, comma 3. There we go. This became a positive. This became a positive. All right, take a moment, answer question 28 using this rule here, negative x comma negative y. Okay, and then our last one is 90 degrees clockwise. So we've got 90 degrees clockwise, negative y comma negative, I'm sorry, y comma negative x. Let's write that rule down. And let me scroll up here a little bit. We've got y comma negative x. So they are changing locations. So I'm going to put a 0 first, and then I'm going to put a negative 5. Change their location first, and then let's see. This 0, the sign is going to stay the same. 0 wouldn't change anyways, and this sign should change here, so that would become positive. So 0, comma 5. All right, I'll give you a moment, answer question 30. All right, now we've got the slope. We are finding the slope of each of these lines. And let's see if I can zoom out there. Oh, a little too much zoomed out. There we go. Okay, so we're going to look back in our toolkit at our slopes. We had 4 types of slopes. Actually, no, it's this way. There we go. Okay, so our 4 types of slopes here, you'll notice we've got positive, we've got negative, we've got undefined, which is a vertical line, and we've got 0. So I'm going to give you a moment to answer those questions. I'm just going to go over one. Like, for example, we've got here 7 over 3. So remember, slope, vertical change over horizontal change. And then making sure we also simplify it if necessary. So 7 over thirds, that's just going to stay 7 over thirds. It's not going to simplify. But we always want to write it in simplest form. So for example, a fraction of 2/4 would become 1/2. Or a fraction of 6/3 would become 2. Okay, so here, if you notice on our negative slope, we went down 4 to the right 8. That's negative 4 over 8, and we would want to simplify that to negative 1/2. Now, I'll show you really quickly a great tool, Desmos Scientific Calculator. Go here, open up that scientific calculator, and you can put in a fraction here. So we could put, like, for example, negative 4 over 8. And it would give us our simplified answer, and we want it in a fraction form, so it would put it back into a fraction for us. So you can always use, your own calculator if you want to open up a scientific Desmos calculator. That would be great. So I'm going to give you a moment. Let's answer question 31. I'll create this for you, make it a little easier. Okay, let's answer question 32. What type of special slope is that? All right, let's go to question 33. And then 34. What type of special slope is that? Okay, now we're going to be using the slope formula that can also be found in your toolkit. We've got that here. So we have a few examples, y2 minus y1 divided by x2 minus x1. So remember, vertical change divided by horizontal change. So let's go back here. I'm going to label this as x sub 1, y sub 1. It's my first coordinate. X sub 2, y sub 2, my second coordinate. So remember, y2 minus y1, all divided by x2 minus x1. So our y2, I'm going to use 2 minus negative 6. And that's going to be all divided by negative 18 x2 minus x1, negative 3. And if you want, we can put that into our scientific calculator. You can just type in 2 minus negative 6. Well, that's really going to be 2 plus 6, so that's going to be 8. And then we have negative 18 minus a negative 3, so that's really going to be 18, negative 18 plus 3, and that's going to be a negative 15. So our answer here, 8 divided by negative 15, that's just going to be a negative 8 over 15. We have one positive, one negative dividing properly. So if you wanted to type this in here, just as kind of a little example, let's go here. We had, what did we have? 2 minus negative 6. Let's just check our work. Whoops. 2 minus negative 6. And I wanted you to see how to actually type it in. And I've got negative 18 minus a negative 3. Negative 18 minus negative 3. And then you'll see here we can then convert our answer back into a fraction, negative 8 over 15. Okay, take a moment. You're going to find the slope for question 36. All right, now we're on question 37. Find the slope of a line parallel to each given line. So with question 37, our equation here is y equals negative 7 over 3x plus 4. So our m, our slope for that is negative 7 over 3. And let's remind ourselves in our toolkit what we wrote about parallel lines. So parallel lines have the same slope. The same slope here. All right. So then if we go back to our question, if our slope is negative 7 over 3, we would want it to be the same if the lines were parallel. So that would also be negative 7 over 3. Give you a moment, answer question 38. Okay, and for question 39, our slope is 8/3. So if we look at what we wrote about perpendicular lines, they're opposite reciprocals. So opposite means changing from positive to negative, and reciprocal is like taking a fraction and flipping it. So you notice here's an example of opposite reciprocals. 2/5 would be flipped to a negative 5 over 2, because we want it to be an opposite as well. So if we look at our example here, we're going to take 8 over 3, we're going to flip it, and we're going to change its sign. So negative 3/8. And then I'll give you a moment. This is our last question. Go ahead and solve number 40.